This video is for the transformations of exponential functions notes. So when we do transformations, here's all the different things that we can do to an exponential function. So b to the x is our parent function. So if we multiply the function by a value, so here they're using the letter a, we can also alter the exponent. We can add or subtract to it, and then we can add or subtract to the entire function. Okay, so h, if we do anything up here to the exponent, h is the horizontal shift. So positive, so if we add something, it's going to shift it left. If we subtract something, it's going to shift it right, left and right this way on the graph. So k, if we add or subtract something to the end, this is the vertical shift. So if we add or subtract something to the end, we're moving the function up or down on the graph. So if we add something, it's going to shift it up. If we subtract something, it's going to shift it down. All right, and then a, if a is negative, so if this is a negative value, the function is a reflection across the x-axis. And then if a is greater than 1, this represents a vertical stretch. If a is in between 0 and 1, this represents a vertical compression. And so what we mean by that, a vertical stretch, think about taking something and stretching it vertically this way. A compression is taking something and you're pushing it down this way. So if you stretch it, it's going to get tall and skinny. If you compress it, it's going to get short and then it's going to get wider. It's going to kind of push out this way. So what we're going to do is we're going to identify the parent function and then describe the transformations. So for number 1, our parent function here is 3 to the x. Okay? Our transformation, we're adding 5 to the end. So adding 5 means we're going to push this thing up 5 places on the graph. Okay? 2 to the 4th to the x minus 1. So the original function or the parent function is 1/4 to the x. That's where we're starting. And then our transformations here. So the 2 right here, that's an a value. It's greater than 1. So we've got a vertical stretch times 2. And then up here, so if it's minus 1, that's this up here. We're messing with the h. Minus, we're going to the right 1. And that's just the movement you're making. So I'll show you on this last one kind of visually what it looks like. All right, so number 3, our parent function here is 4/3 to the x. And then our transformation, so let's start. We've got a negative out here in front. That means we're going to reflect this over the x-axis. Okay. Then we're adding 2 to the exponent, which means we're going to go left 2. And then we're adding 7 to the end, which means we're going to go up 7. Number 4, our parent function here is the 5 to the x. Our transformations, we're going to start at the beginning. So the 1/2, that is a vertical compression by 1/2. Then we are subtracting 4 from the x, so that means we're going right 4. And then we're subtracting 2 from the very end, which means we're going down 2. Okay, so to see what this looks like. So here we've got 2 to the x plus 5. So our parent function here is 2 to the x. And so I'm going to make a quick little table here to show you the points. 0.25, 0.5, 1, 2, and 4. And then the function they've given us is this one, so I'm going to put, that's going to be this table. Our points would be negative 7, 0.25, negative 6, 0.5, negative 5, negative 4, negative 3. So the y values are all the same, but look what has happened here. They're the same when the x value shifts to the left 5. Okay? So when we're saying shift, that's what's happening. If we're shifting it left and right, we're shifting the x values. Okay? So if we would graph this one, negative 5, 1, 2, 3, 4, 5, positive 1, 2, and then 3 is 4. Okay. Our original function was coming through here, so we have shifted this to the left. I'm going to show you on the graph what that looks like. So if we've got 2 to the x, that's our parent function here, or our starting function. And then if we do 2 to the x plus 5. So the blue is my original, and so you can see here we've taken the whole function and shifted it left. All right, so what that does to it, the domain stays the same. It's still all real numbers. The range, y is still greater than 0. The end behavior does not change. As x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches 0. The y-intercept, though, has now changed. So to find the y-intercept, we make the x value a 0. So 0 plus 5. Okay? So that's 2 to the 5th. 2 to the 5th is 32, which means my y-intercept is going to be at 0, 32. So if you're ever trying to find the y-intercept, make the x value a 0, solve it, and that's how you find your y-intercept. And your asymptote here is still y equals 0. It's not going to cross that x-axis. Okay? All right, so let's look at some more examples, what these look like on the graph. So here we've got a third to the x minus 2. So 1/3 to the x minus 2, that's our original function. So again, if I make me a little table here, negative 2, negative 1, 0, 9, 3, 1. And then if I make a table for the transformation, so what's happening here, negative 2, hang on, let me pull that one up, I can't read my notes. So if we do 1/3 to the x minus 2, Control T. Okay, so my negative 2 value is now 7, sorry. 1, negative 1. So now what's happened is the y value shifted. So if I'm just adding or subtracting to the end, my y value is shifting. So if I graph this one, negative 2, 1, 2, 3, 4, 5, 6, 7, negative 1 and 1, 0 and negative 1. So now what's happened is this thing has now shifted. Sorry, and that's a horrible line. But you can see here on the calculator as well that it is shifted down below the x-axis. Okay, so left and right shifts are not going to change like the asymptote. Up and down shifts, adding or subtracting to the end, are going to mess with that asymptote. So the new asymptote is, so I did a really bad job drawing a straight line there. But the domain is still all real numbers. The range now, so here y is always going to be greater than this value, negative 2. Okay, As x approaches infinity, so that's going this way, y is going to approach negative 2. As x approaches negative infinity, y is going to approach infinity, so that's going this way. The y-intercept is 0, negative 1, and the asymptote is y equals negative 2. So your asymptote and your range are always going to fall in the same area. Okay. Okay, so 1/2 times 3 to the x plus 1. So I'm just going to do one table for this one. X and y. Negative 2, negative 1, 0, 1, 2, 1.05. And so what's happening here, and I'll show you on my notes, our values here, our y values, you can kind of see how they're changing. They're getting larger. The y values are increasing here, but not here. Okay, and that's because of this plus 1, because we're shifting as well. So it's kind of harder to see when you're doing more than one transformation. All right, so if we graph this one, so 0 and 1.5, 1 and 1.25. Why is it doing that? Oh, I'm sorry. That should be, I was looking at the wrong list. This should be 2.5. So 1 and 2.5, and then 2 and 1, 2, 3, 4, 5. Okay. And so this is my asymptote here now. So my domain is still all real numbers. On this one, though, my y value is never going to get less than 1, so y is always going to be greater than 1. So again, always look for the end. What's at the end here? That will kind of let you know. The end behavior, as x approaches infinity, y is going to approach infinity. As x approaches negative infinity, y is going to approach 1. My y-intercept is 0, 1.5. My asymptote is y equals 1. Okay, so anytime you're adding or subtracting to the end here, that's when it's going to mess with your range. So for this one, let's just look at what happens here. So the domain is still going to be all real numbers. But since we have this -5, my range is now y has got to be greater than -5. As x approaches infinity, so here's how I know this. 3/2, this number is bigger than 1. So that means that this is going to be growth. It's going to look this way. It's going to increase to the right. And so you can kind of figure out what your end behaviors are. As x approaches negative infinity, going this way, f of x or y is going to approach -5, which means my asymptote is going to be y equals -5. Okay, and then on this one, all my key features are going to stay the same because I am not messing. I'm not moving it up and down. I'm only moving it, so this -2 means I'm moving it to the right, taking that whole function and moving it to the right by 2 values.